Hey guys, so I just wanted to explain what you guys are going to be doing in this very short lab, maybe not very short. I'll give you class time today and Monday to complete it, and yeah, hopefully that'll be enough time. If you finish it before Monday, that's fine, but I'll still give you class time today and Monday, so don't feel pressured over the weekend. I want you guys to still be able to have a weekend, so you have class time on Monday to finish it, so no pressure there. So I'll just explain the simulation. Once you open the simulation, at the very first part, you'll go to the introduction. If the simulation is not working for your computer, then there is an extension called, what is it called? I think it's called Tier something. Yeah, this one. Tier PJ Applet Runner. If it's not working, then install that simulation. But it should work. It should work on your computer. So I'm pretty sure it will work. But just in case it's not working, then you want to install that extension on Chrome. If you're using a MacBook, I have no clue. I hope it just works for you. So once you get to the introduction tab, you can just play around with the guy and see what's happening. One thing that I ask you to do is to try and move him with your cursor at a constant speed. Try and move at constant speed. Hope you can see that that's not very possible. I mean, it's difficult to do. And as you observe that, that's you can play back and see that the arrows, the slider for velocity kept fluctuating, so did the slider for acceleration. An explanation for that can just be the friction in the surface. Being a human being, it's impossible to keep that thing moving at that constant speed. There's walls here, you can take them out if you want. You can take them out, and then this guy can just disappear, right? Disappear. So just play around with it. But the actual lab starts on the charts. Here on the charts, I want you guys to look at these position time graphs on different scenarios. So for example, let me just put random values. Like if I put 0, and then I give him a velocity of 5, what's going to happen? Try to pause it each time just before he hits the wall, because if you let him hit the wall, then your graph will have funny things like what you see. So each time try to pause it just before he hits the wall, such that you have a good graph. So let me just try that again. 0 and 5 meters per second. You can just click on this side here to set any speed that you want. So 5 meters per second, if I let him move and then pause him just before he hits the wall. Yeah, there we go. So you have your position time graph, you have your velocity time graph, and you have your acceleration time graph. I hope you can see that since he was moving at a constant speed, the velocity time graph is just a straight line. And since I didn't put any acceleration value, the acceleration time graph is also just a straight line. The position time graph is showing me a straight line with a positive slope, right? A straight line with a positive slope, because he's going at a constant speed. So if it's a constant speed, this tells you, and this is what you're going to be learning, that your position time graph will be a straight line with a constant slope. So that's what you're going to be doing. And once you do this, you go to this worksheet, and then you'll post a screenshot. And I showed you how to do it. Once you push Windows plus Shift and S, Control Shift S, this happens. And then you just take a screen clip of that area. It will be copied automatically, and then you can just paste it here, Control V. So that's all you have to do, right? For the velocity time graph, again, Windows, Shift S. You can't see me doing it, but I promise you that's what I'm doing. Velocity time graph, small piece there, it's already copied automatically, and then paste. Acceleration time graph, Windows, Shift S. Screen snap or snip or clip. Paste. Is this the graph you expected? You can be honest with yourself. I am saying yes because that's what I expected. Explanation. So position time graph is constant positive slope, right? This is going to help you practice describing graphs. So please be very intentional about this. Constant positive slope. VT graph is zero slope. Zero slope or straight line at V equals straight line at V is equal to 5, and acceleration time graph, AT graph, is again zero slope at A equals 0, right? So this is how I want you to work this out or do this lab, and there's quite a bit more for you to do, so I know you will have fun doing it. For some of them, like let me look at the very last one. So X is -10, V is 10, and A is -5. So go fill that in. X is -10, we type that. V is +10, and A is, was it -5? Yeah, -5. So remember to pause this guy just before he hits the wall. And if you click show vector, it would help you see what's happening in each case to the velocity and acceleration. So I'm going to pause him just before he hits the wall. Perfect. So, and I will do the clippings. Remember Windows Shift S. Take a clip of the position time graph. It's already copied. Paste it. Go to the same thing. Windows Shift S. Clip of the velocity time graph. Paste. And then lastly, Windows Shift S. Acceleration time graph is copied and paste. Is this what I expected? Again, I'm being honest, yes. Now the descriptions. The position time graph is concave down, right? Concave down, or you can say curves downwards. Right? What it shows me is that the position of the, so if you consider increasing, you can think of it as the position increases and then decreases back to -10, right? Position increases to 0, and back to -10, and decreases back. The position increases and decreases, right? Increases and decreases. You can say VT graph speed. I hope you can see that the speed starts out positive. It starts out with a positive velocity that's about 10. Yeah, you can see that it starts out with a positive velocity. The velocity decreases up to a velocity of 0, right? And then it increases in the negative direction. Let me show you this again on this thing. It starts out with a velocity, go back to the beginning. It starts out with a velocity of 10 meters per second, which was positive, a positive velocity. The red arrow is showing you a positive velocity. That velocity goes on decreasing as the acceleration is increasing. That velocity goes to 0 because you can now see the red arrow has absolutely disappeared. And then that velocity starts increasing in the negative direction. So he gets a negative increasing velocity, right? I hope you can write those descriptions in this thing. And if it's not fitting in the table, just make it as small as possible until it all fits. VT graph starts with positive velocity, decreases to 0, and increases in opposite direction, right? Again, the purpose of this whole lab is so you understand descriptions of motion graphs, right? Because when you see this graph somewhere, and you'll see this graph a lot, immediately in your mind you'll know that this is someone who starts with a positive velocity, their velocity decreases to 0, and then it increases in the negative direction because because their acceleration was negative. So you start out with a positive velocity, but since you have a negative acceleration, so your acceleration time graph will say acceleration time graph. The acceleration time graph will say negative constant acceleration, right? Because you have a negative acceleration, your velocity has to decrease and then start increasing in the opposite direction. I hope this helps. If you have any more questions, please let me know. I'm going to leave now. I was going to leave these answers there, but I'm not going to leave them there. You guys will have to do this on your own. All right, that's it. Bye.